So in recent years, the team at E2 Design Lab have worked on a series of projects that brought together principles and experience from research and practice. And it's sort of funny because we've sort of been in this parallel universe to Chris. It's like Chris through academia, us through practice more so, but crossing over a little bit. And there's a lot of, I haven't talked a lot. It's times like these where we check in and compare notes, and it's remarkably similar, I hope. So, and in that time we've produced some precedents and guidelines for passively irrigated street trees, and today I'd like to talk through some of those issues that influence a healthy tree. Get myself in order. So a simple definition there of what is a passively irrigated street tree. It's pretty much just getting the water there without using pumps or anything. But it differentiates. I've heard passive irrigation applied also to where you go around and manually water trees, but that's not what we're talking about. Chris has covered that. That's fine. Now, what I'm not talking about today is these things here. This is just going to be about the things that matter most for getting stormwater to contribute to the best possible outcomes for a tree. And we need to narrow the field down a bit to fit in 20 minutes. So I'm not really talking about wicking systems or a bioretention system with a tree in it, or systems that are primarily designed for treatment. Chris touched on them a little bit, but really, Chris differentiated between larger systems that are trying to do stuff for reducing volume and doing stuff for water quality, but then there's ones where you're just basically trying to design a good, healthy tree. So that's where I'm talking about. Now, before I get on to a bit of a checklist of design features, which is more specifically about when you've decided where you're going to put a tree and how you're going to do it right. Before I get there, there's a few things to consider when deciding where to put the tree. I'm not going to talk about the first 4 things on here. I think there's enough knowledge and guidance out there on this already, and they're the sort of issues you'd be dealing with any sort of tree planting. But for passively irrigated trees, these last 3 things need to be thought about together, and I'm going to touch briefly on them before going on to the particular physical design features. So the next 5 or 6 slides are about a relationship between catchment and tree size. And so here's a rule of thumb starting point that everyone's design can build on. And this is based on the assumption that in situ soil conditions aren't going to be good in a city environment. So how much soil do you need? Different studies say different things, and it differs between species. But if you just take the area of beneath the canopy and say, you need about 350 mils or so of good dirt below there, then you get this volume. And what I've done here is just rearranged it in this shape to reflect real life in the big city, and that is that you don't have the luxury of going down, of going outwards, so you go down. So that relationship is the square meterage of the tree canopy area that you're looking for. Divide that by 3 and you've got your desirable soil volume. And look, there's a lot of leeway in these rules of thumbs that I'm going to be doing here, but even if you adjust the ratios a fair bit, the story's going to come out the same, so bear with me. Now, for this next one, for this next relationship, my colleague Dale Brown did a lot of modelling to track soil moisture in Melbourne conditions with pavement runoff in and evapotranspiration out, which means this model's one of a tree soil cell that isn't exchanging water with the ground around it. I don't expect you to understand that graph. It's really just there to say we did modelling and effectively ran a lot of combinations of catchment area and tree canopy soil cell volume, and this allowed us to predict a Goldilocks zone, which I was supposed to talk about on the last slide. Let me just go back there for a sec. I'll just go back to the previous one. Yeah, okay. So in that relationship I was talking about, the modelling showed that there's a catchment that's just enough to support the soil moisture in your ideal soil volume for your tree. So there's just enough water and too much water, and the bit in between is where we want to be. So the ratio there is the ratio that should provides you with enough water. And out of that, if you put those two relationships together, you get this really rough rule of thumb for Melbourne, where we're saying there's a relationship between your tree canopy area and the catchment area running to the tree of about a 1 in 10. And if you've got that, a reasonably thirsty tree won't suffer much so long as you can have that catchment 10 times as big as the tree canopy. But don't forget, this also depends on having the right soil volume as well. That's a simple rule of thumb for Melbourne. But as I said, even if that was a bit out, that relationship, the following story still holds true. So the trouble with that is, if you look at, you're just not going to get a catchment that's as big as that when you're chasing the sort of canopy cover targets that make a street work well. So for instance, if you got your trees there spaced out at about 15 metres, and the bit of pavement from the crown to the curb is 3.5 metres wide, you've only got about 100 square metres of pavement, which, according to the rough modelling, will only give you if you're growing the tree basically in a confined environment underground, it's got no exchange with the soil around, the soil moisture around it, then you're only going to support ideal conditions for a tree that's grown to about 3.5 metres in diameter. So it's not really big enough. Whoops. But what we're confident of is that the tree will get that optimum soil moisture until it outgrows its catchment. So there'll be plenty of good early growth. And beyond that, it'll need other water, and that might mean manual watering during a long dry spell. But if the tree can connect to deep soil moisture, then it'll have a really important win, and I'll explain more about that in a minute. But even with that help, you still may need to consider a species that'll soldier on in drier conditions. And so I figure that there's two paths you can go down in this sort of scenario, and one is just to lower your aspirations for a big canopy, but the second is to get outside of that containerised underground environment and get the tree connected to deep soil moisture. Now this has got a lot of clicks in it, so I hope the animation, here we go. So now I said I was going to talk about a list of design features, and I'm on again about my favourite rant about connecting with deep soil moisture. So before I get on with those other things, I'll just finish this bit by showing how a few features combine to make that deep soil moisture thing work. So, as you know, runoff from urban areas is flashy. You get a lot of water in a short amount of time. So you need that capture storage to store it and hold it while it gets a chance to infiltrate into the tree growing media. Now often the tree will be using all of that as it comes, but there's other times, like in spring and winter in Melbourne, when there'll be a surplus, and we don't want that surplus to be wasted. I mean, unless it's connected to the ground around it, what typically would happen there is that it'd start disappearing down the overflow. But, and this is why we want to sort of get away from that theory of growing in a pot on the ground, or having a bioretention style drainage layer across the bottom of it. We want to try and get this out into basically do soil moisture banking. Now in all that, drainage is very important, as Chris was telling you about, and we definitely want to guarantee that the top 500 millimetres or so isn't waterlogged. And we don't mind a bit of saturation below that, in including the surrounding soils. And then when the dry comes, the trees use the moisture in the top layers. The moisture below can be drawn up through capillary, This is when the tree's young and the roots are still in the top layers. Now, I think... oh no, I'll leave that to the next slide. I'll just keep going for a minute. In later years, you'll probably find that some of the larger trees may go looking for deep moisture. And again here, I'd like to point out that if you had a bioretention style drainage layer here, it would not only get in the way of allowing that infiltration to go on, but also tend to break the capillary when it's time to come back out of deep soil moisture again. I mean, capillary will work even with a very fine sand. It should work for your tree growing media. But if you've got a layer across the bottom there of coarse stuff or rock, it'll tend to break that opportunity for the deep soil moisture to come back into it again. So, I mean, I've very schematically just shown this little drain off to the side there, and it's a whole lot more complex than that, as you would have seen from some of Chris's stuff. And we'll touch on that more later. What's next? All right, well, look, that's a bit of the relationship with deep soil moisture, and so let's go on to those features to consider for designing once you get to an individual tree. So I was going for 10 features, but I couldn't narrow it. It's 11. A lot of these things you're already doing, but I think it's just useful to categorise them in this way, in the form of a design checklist. And you'll see here there are many ways to deliver each feature, and sometimes you can deliver 2 features combined in one. But my intention here is that you could work your way down through a list like this and ask, okay, how do I address this thing? How do I address this thing? These first 2 are about how we intercept the water and get it to the tree, and often these things are done together. For example, your inlet may be a grate or something to keep out litter and debris, or a permeable paving, which would also keep out the sediment. And what I mean here about a maintainable window is particularly about where the sediment gets caught up, because as Chris was saying, this can seriously compromise the opportunity for your water to infiltrate into the tree growing media, and will result in a lot of bypass. And as Chris was saying, we need to think about how that sediment gets removed. So I'm going to show you here a lot of different forms, and I'm not really going to start passing comment on which ones do well and which ones don't. And I think that's almost your duty. Like, some of these forms are going to suit your circumstances better than others, and it means that you might choose it anyway. But you've got to think about how am I going to maintain that window of permeability? How, what's my way about keeping it open? I've got a feeling some of these photos are really blurry. I was doing them late last night, and everything looked a little blurry. But so you've got, look, on the first column there we got permeable pavements. So that's not only the means of intercepting and getting into the tree, but it's also that a form of pre-treatment, and that becomes your maintainable window. You got to go back there and pressure wash it and everything. Interesting, we did some stuff for the city of Melbourne, and you can start off with permeable pavements that are, we've got 5 millimetres, 5 metres an hour permeability, which rapidly drops to maybe 100 or so, which is still not a fail for a tree, but you've got to keep an eye on it, and you've got to be willing to maintain it. The second one is your typical sort of tree pit, which can be with or without a grill for litter and debris, but I would call the maintainable window in that case is the earthen surface within the tree pit itself, which will be accumulating sediment. What are you going to do about keeping that open? How do you maintain it? And then the last one there is probably a poor example of a vegetated surface. advantage of that one being that the vegetation will, as in bioretention systems, will tend to keep the surface open. You might have a secretion of sediment, which, when combined with the plants, will last for longer before it seriously compromises the infiltration. Couple of other different forms of capture, and these are images stolen from Water by Design's new document, which I can't remember the title of, but it's a good document. And so you got that sort of loop system where the water's coming in at one end and coming out at the other. So your maintainable window there, well, actually Water by Design showed this example. I think it was from Brisbane City Council, where they had a permeable plug in the end to keep a lot of the stuff out, but it quickly blocked up. Other than that, your maintainable window is actually the inside of that pipe system, which you've got to be able to flush from time to time. So, and the second one, as Chris was showing, was the tree net arrangement in the curb. This is the second column here, which is a bit of pre-treatment there. And in that case, I would call the maintainable window partly that, partly also the inside of the well, which you might have to refresh from time to time. The last image there on the right is a form of pre-treatment as well, sediment control, to try and alleviate those issues before it gets to the maintainable window. Now, capture storage. So, yeah, I've got my own rule of thumb for capture storage. It's in so many different forms, and I'll talk about that in a minute. But as far as some rough sizing go, my thoughts about this are that, you got the nasty long dry spell like we get now in Melbourne in summer, and you've gone weeks, and then you get this flashy little cup, few mils of rainfall, and you want to get it all. And I feel like if you're going to do nothing else, that's what you should be sizing your capture storage for. If you got 2.5 mils of rain, you've lost the first mil to evaporation off the pavement. So if you look at the sort of area there, that's 15 metres between trees, the crown of the road to the pavement, 2.5 mils of rainfall means you've potentially got 150 litres. So to me, that capture storage volume should be aiming to be a little less than a bathtub. And if you can get that to the tree, you're probably doing well. And as Chris was saying, Jasmine's monitoring was showing that a tree could still use that amount in 2 days in the peak of summer. But really, I think that's the best you could be hoping for. And it's those summer conditions that you're trying to design these systems for. So if you can't get any bigger than 150 litres, aim for 150 litres anyway. And again, there's various forms. Let's go through some of those other ones again. In the case of on the left, they're the classic tree pit. It's just it's the equivalent of your extended detention there, that temporary ponding. And in the case of the pipe in and out, your capture storage in that case is the gravel trench around it. The water's going to quickly transfer from the pipe to the gravel trench. It's going to more slowly transfer into the growing media. So you're trying to get 150 litres out of the voids in the gravel there. And likewise on the right, in the tree net thing, you've got the well there and the volume of the well and the gravel around it. Aim is to try and get 150 litres out of that airspace in the voids. Now the rest of the list, a lot of this stuff I'm just going to flick through really quickly because there's guidelines out there that can help you with them, and it's not really the main game. What I'm here is to remind you that you work your way down the checklist and think about how I'm incorporating these things into my design. So there's things about safety, the safe interface with surrounds, and a lot of the councils, City Kingston was one, have developed their own sort of like standards on that, and they're appearing in some of the guidelines. Port Phillip have done a lot of work there too. Soil characteristics, there's various ones around that will guide you towards good tree mixes, and there's a new guideline coming out which E2 helped with that I know of one. So there's a specification for tree media that's basically done by a proper soil scientist there. Likewise, soil volume, we talked a little bit about that before. I'm not going to go into it. The guaranteed aerobic zone and the connection to deep soils and deep soil moisture we've talked about. Lots of ways to deliver it. Here's the checklist to remind you, how am I doing it? How am I going to do it? Now, barriers to protect adjacent assets and structural support, I'm just going to chuck together here because I've got a diagram where I could talk about them both at once. Chris touched on this with talking about how you might combine that drain. In fact, I'll just go to the picture. The roads guys are going to want, I'm an engineer, so we want the pavement to be not compromised through being saturated. So our experiences with various councils, there's various degrees of people being pedantic about this. In some cases, the gravel this is a stratovolt system, but regardless of whether it is or not, you've excavated. You need to put in an Aggie pipe there with a gravel trench in it to ensure the guaranteed aerobic zone. That could potentially also be the drain at the side of the road subbase that the road engineers are looking to put in. They can be one and the same. In some cases, didn't want to share, so you might end up with the road drainage one, an impermeable barrier just for that edge. I'm not talking about underneath, just for that edge, and then repeat it again on the inside. Structural support. See that red line there? That's like the zone of influence of loading from a vehicle. So with this example, it was a stratovolt system. Those stools are taking the load, and in this case, on the bottom there, you'll see a detail, and it's got the crushed rock under that part of the cell because it really needed that additional strength further out in the cell. What we're trying to do there is not continue the crushed rock out because it's going to break that capillary and the access to deep soil moisture. So the bedding for the rest of it was not crushed rock. It was. In fact, I don't know, Ben, maybe we can talk about this later in the panel. And if it is in a stratovolt system and you don't need that structural support out in the tree cell itself, you're still going to need to think about how you can have that load transfer. Pretty much at the end here. Now, the other thing was about the thing on the checklist was a repairable growing media, and again, Chris touched on this. You want to think about, I'm putting something in the ground here, and I need to anticipate that someone's going to rip through it, putting in another service at some point. And are we happy here to remove a row of stratovolt cells and repair it and replace them? And are we going to go to a cobble system? I think people in the City of Melbourne were suggesting that they rathered that versatility because it was going to be easier and less specialised to repair again. I'm not saying which is best, I'm saying these are things you need to consider. And I'm going to finish up by jumping back out of that talk about the design checklist and just go back to something I was talking about earlier, and some final comment. And if you want to, there you go. If you want to get that shady streetscape, just remember that in your typical sort of scenario, passive irrigation is going to accelerate the growth in early years, but you'll get to a point where the tree outgrows its little catchment. And what happens then? It needs to find other sources of water. Passive irrigation will still be helping it in those times, but its soil cell volume will be very important at that point. But let's think about where we can get that other water from and consider deep groundwater. And I would sum that up by saying all the stuff above ground has got a lot in common with bioretention systems and WUSD design. and the below ground stuff has got a lot in common with the proven practices of tree people. And I would qualify that by saying that it's different for bioretention systems, and it's really about the hydraulic loading. With a bioretention system, you might have it sized to less than 1% of its catchment. You'll have a whole street running into a bioretention in the corner, down the corner of the street. Because that same street's got all these street trees along with it, all these windows. The hydraulic loading on any one tree is going to be a whole lot less than bioretention systems, and that's why a simpler drainage system applied to a tree is more appropriate. It's not your bioretention style solution. Those things aren't needed. So look to the tree guys for advice below the ground, look to the worsted people for the above. And that's it.